All right, welcome back to one of our revisions. So here was question 1 on our equivalent ratios assessment. Here it says select all the true statements. And so we have some smiley faces, some triangles, and some squares, and we need to pick from some of these ratios. And so before we start reading, first thing we should do is label, right? So we have our smiley faces, right? Our triangles, and then we have our squares. And so I saw students do this. We have 1, 2, 3, 4, 5, 6 triangles, 6 smiley faces, 2 triangles, and then 4 squares. And so here we read, right? The ratio of triangles to squares is 2 to 4. Well, how many triangles are there? There's 2, so I can do 2 triangles. The word 2 we can say is a colon to our squares, which is 4. This is a 2 to 4, right? 2 to 4. And so, yes, they are equivalent. Here it says the ratio of squares to smiley faces is 6 to 4. Well, how many? Remember, order matters on these, right? A lot of students chose this one because, right, there's 6 smiley faces and 4 squares. But what's important is we want to recognize that there's 4 squares to 6 smiley faces. Since these are flipped, this is not a possible answer. We can cross this out. Here we have the ratio of smiley faces to triangles is 6 to 4. Well, yeah, there is 6 smiley faces, but there's only 2 triangles, so it's actually 6 to 2. So this one's not possible. And then finally, there are 2 squares for every triangle. Well, this is having you batch up your triangles to squares. What we can see here is that, yes, right, we do have 2 squares for every 1 triangle, right? So I put that line there. And so, yeah, this is 1 because for every 2 squares, there's 1 triangle. And we call that a batch. There are 2 triangles for every smiley face. Well, there's 6 smiley faces and 2 triangles. There's actually 3 smiley faces for 1 triangle. So we know that that one's not your answer, which I accidentally gave the answer here, right? We can see that for every 1 triangle, there's 3 smiley faces when we cut it evenly. And so there are 3 smiley faces for every triangle. That was our next one. I think because question 2 is right on the page, we can just go right to it. Here, question 2 says, select all the ratios that are equivalent to 8 to 6. And so we have 1, 2, 3, 4, 5. We have 5 tables, right? So this can be our, 8 to 6, right? We can do that for each. 8 to 6, 8 to 6, 8 to 6, and then finally 8 to 6. So here we have 4 to 3, and so we're making a table to see if this works on our first one. And so what we know is we can do 8. How do we get from 8 to 4? Well, we do 8 divided by 2. And what we know about equivalent ratios is whatever we do to the left, we can do to the right. And so 6 divided by 2 is 3, so this is possible. Going into 6 to 8, a lot of students chose this one because it was flipped. Remember, order matters, right? Wherever you see how we're going 8 to 6, how it's going down. This means we're multiplying by something less than 1, while 6 to 8 is going up, so that means we're multiplying by something greater than 1. This is not equivalent, right? You can't just change the order and expect the ratios to be equivalent, so we can cross that out. Here we have 16 to 12. Ask yourself, how do you go from 8 to 16? Well, yeah, you can just multiply by 2. And so if the other side is equivalent, both ratios are equivalent. 6 times 2 is 12. So that's also a possibility. Here we have 10 to 8. Both of these added 2, right? But if I was able to reduce 10 to 8 down, that would be 5 to 4. And so we're not multiplying both sides by the same number. So that means this one is not equivalent. And then finally, 7 to 5. Both of them are subtracting 1. Right? We're not multiplying by the same number or dividing by the same number. So that means this one is also not equivalent, which gave us these two possible answers as ones that were equivalent. And so when you get this problem on your retake, all you need to do is make a table, go through each point, and see, are they equivalent? And remember, equivalent means you multiply or divide both sides by the same ratio. All right, so for question 3, we have a mixture of purple paint contains 6 tablespoons of red paint and 15 tablespoons of blue paint. To make the same shade of purple using 35 teaspoons of blue paint, how much red paint would you need? Use the double number line below if needed. And so here, what we want to do is we can use this double number line. And so let's look at our red paint. We have 1, 2, 3. We have 3 tick marks until we get to the number 6. So what could we add over and over to get to 6? Well, if I split 6 into 3 equal groups, I get 2. And so that means I can skip count by 2. So 2, 4, 6, 8. I'm just adding 2 over and over. 10, 12, 14, 16. And now, right, I have 15, and I want to be able to go from 0 to 15 in 1, 2, 3. So I want to split 15 into 3 equal groups. Well, 15 divided by 3 is 5. So that means I can skip count by 5. So 0 to 5, 10, 15, 20, 25, 30, 35, 40. And so now, right, this problem asks, right, how much red paint would you need to use, right? So if we have 35 teaspoons of blue paint, so blue paint, 35 teaspoons, we could see here that we're going to use 14 teaspoons of red paint. So that means 14 teaspoons was our answer. And for funds, right, this number of batches is 1, 2, 3, 4, 5, 6, 7. This is 7 batches. And so how you could have quickly used your number line is you could have got this 5 here and then multiplied by 7. And right, this goes back to equivalent ratios. If I multiply one side by 7, right, I need to multiply the other side by 7. 2 times 7 is 14. 5 times 7 is 35. Let's move on to question 4. So question 4 had Lynn rode her bike 2 miles in 8 minutes. She rode at a constant speed. Complete the table to show the time it took her to travel different distances at this speed. So we went from 2 miles to 1 mile. It took her 8 minutes to travel 2 miles. So how much would it take her to travel 1? Well, remember, whatever we do to one side, we need to do to the other. So I can do 2, right? What divided by 2 divided by what is 1? Well, anything divided by itself is equal to 1. So 2 divided by 2. Whatever I do to the left, I need to do to the right. And so I do 8 divided by 2. And 8 divided by 2 is 4. And so that means this row says if I traveled 1 mile, I would go for 4 minutes. But now we have elapsed time. We have from 4 minutes to 1 minute. And so you could either use the 8 or the 4 to get here, but we can do 4 divided by 4 or times 1/4. 4 divided by 4 to get to 1, which means we do 1 divided by 4. And now there's 2 ways to do this, right? So we have 1 divided by 4, right? And there's 2 methods you could have done here. First method is going back to 5th grade where you guys learned that division can be represented as a fraction. And so what we know is our dividend is our numerator and that our divisor is our denominator. And so that means if you just wrote 1/4 here, you were correct. Or you could have done long division, right? 1's our dividend, so it goes inside our division symbol. 4 is our divisor, so it goes in the outside. How many times does 4 go into 1? 0. Because I have nothing to carry down or to add, this means I need to add a decimal and bring it up. So I add a decimal and bring it up to our quotient, then add a 0. 4 goes into 10 2 times. 2 times 4 is 8. 10 minus 8 is 2. So I add a 0, bring down that 0. 4 goes into 20 5 times. I'm left at 0. So that means my answer is 0 and 25 hundredths. So if you wrote that in 1 minute we travel 1/4 of a mile, or in 1 minute we traveled 0 and 25 hundredths of a mile, you'd be correct. All right. So for question 5, we have solve each of the following. So I put the definition here that a unit price is the price for one item, right? How much you spend for one item. Here it says 3 movie tickets cost $36. So that's saying these 3 movie tickets cost $36. And so what we want to ask ourselves is, how do I evenly split $36 into 3 equal groups? Well, I can do 36 divided by 3. 36 goes into 3 one time. 1 times 3 is 3. 3 minus 3 is 0. Carry down our 6. 3 goes into 6 2 times. 6 minus 6 is 0. And so that means the cost of each ticket is $12. And so that means each ticket here costs $12. As a result, the price for one ticket is $12. All right, let's go to part B. So part B says 3 ice cream cones cost $8.25. So that is going to be what we're going to have to use. At this rate, how much would 2 ice cream cones cost? Well, step 1, get the unit price. And so what we want to do is we have our 3 ice creams, right? So if I was to just draw that out real quick. I don't know how to draw ice cream. We'll call it like a bowl, I guess. That's ice cream, right, guys? I don't know. I teach math, not art. All right. All right, I think that's ice cream. And so these 3 ice creams cost $8.25. What we want to know is, how much do one of these ice creams cost? Well, that means we're going to have to split it up into 3 equal groups. And so I get $8.25 as my dividend, 3 as my divisor. And so I like to write my multiples sometimes just to help me. So I can, if I'm struggling with the 3's, I can do 3, 6, 9, 12, right? I'm just adding 3 over and over. So this way I'm not doing this in my head. I'm doing it the first time just so I have it. And so these are all my multiples up to 10, and that's really all I need. So we can start. 3 goes into 8 how many times? Well, 8 is in between 6 and 9. So that means 3 goes into 8, 1, 2. It goes in 2 times. 3 times 2 is 6. So 2 times 3 is 6. 8 minus 6 is 2. I'm now at my decimal. And whenever I get to my decimal, I carry it up. And then I can bring down my 2. 3 goes into 22. 1, 2, 3, 4, 5, 6, 7. We can see 22 is in between 21 and 24. And so that means 3 times 7 is 21. And so that means 7 goes in my quotient. 7 times 3 is 21. 22 minus 21 is 1. I can now carry down my 15. 3 goes into 15, right? 15 is in between. Actually, 15 is right here. So 1, 2, 3, 4, 5. So that means 3 goes into 15 5 times. And so that means, right, the unit price, right, cost per ice cream is $2.75. And so we want to know the cost of 2, right? And so what we need to do is multiply this by 2, or you can just add it. You know what I'm saying? You could just add it, but I'm going to show you how to multiply. And so here, right, we're going to multiply to get the cost of 2 ice cream cones. So one ice cream is $2.75. And so we get $2.75 times 2. And so whenever you multiply decimals, you want to keep track of how many decimal places. So we have 1, 2 decimal places. And so that means I'm going to have to add those 2 decimal places into my product. And so 2 times 5 is 10. Regroup my 1. 2 times 7 is 14. 14 plus 1 is 15. Regroup my 1. 2 times 2 is 4. Plus 1 is 5. Remember, we're multiplying decimals, right? It doesn't make sense for 2 ice creams to cost $550. And so I bring down my 2 decimals places, and I need to add back those decimal places, right? So we had 2 decimal places, so we add back 1, 2, and so that means we go to the left 1, 2 decimal places. And so that means 2 ice creams costs $5.50. And that was your answer for part B. Now, part C says 3 bananas cost 99 cents. At this rate, how much would 5 bananas cost? Now, right, we can get our unit price again. We already did our multiples of 3. And so we know we have to get our unit price and then multiply that unit price by 5. And so here we get 3 bananas costs 99 cents. We want to know how much does 1 banana cost. And so to do that, we need to divide. So we get $0.99 divided by 3. 3 goes into 0, right? 3 is bigger than 0, so it goes into it 0 times. We got to our decimal, so we need to bring our decimal up to our quotient. 3 goes into 9 3 times. 3 times 3 is 9. 9 minus 9 is 0. Carry down our 9. 3 goes into 9. 3 times. 3 times 3 is 9. And so we end up getting that one banana costs 33 cents. We want to know, how much does 5 bananas cost? Well, this is kind of like, I cannot write the word banana for some reason. Costs, right? 1 times 5 means I need to do 33 cents times 5. You guys can't see that. And so to get how much 5 bananas cost, I need to multiply $0.33 by the 5 bananas that we're buying. Or you could add 33 cents over and over. That works too. So just like before, we keep track of our place values, right? Our 33 cents terminates in the hundredths place, which is why we have to add back 2 decimal places, right? There's no decimals here, so you don't have to worry about that. 5 times 3 is 15. Regroup our 1. 5 times 3 is 15. Plus 1 is 16. Regroup our 1. 5 times 0 is 0. Plus 1 is 1. Now, this is why we keep track of our decimals. It doesn't make sense for 5 bananas to cost $165. And so I have to add back my 2 decimal places. So we go 1, 2. And so this means that 5 bananas cost $1.65. And that was our answer for 5. All right, so for question 6, we have a bag contains 120 marbles. Some are red, the rest are black. There are 9 red marbles for every black marble. How many red marbles are in the bag? Show your reasoning through a tape diagram, and then explain your reasoning. Well, we know our ratio here. We were just told that it's red marbles to black marbles. And we got that there's 9 red marbles for every black marble. That means there's 9 red marbles for every 1 black marble. And this says we want a tape diagram. So first off, we want to get our red marbles and label our black marbles. And we want to start with our original ratio. So we draw 9 boxes to represent our red marbles. Now, I'm not an artist, meaning it doesn't need to be perfect. Yours doesn't need to be a perfect box. But what you do need is 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes to 1 black box. And so what we were told is that there's 120 marbles in the bag. We want to make sure to put our hole right here, right? We have 120, not 160. So we have 120 marbles in the bag, and we want to know how many of them are red, how many of them are black. Well, to get this, we need to split 120 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal groups. And so there's 2 ways to do this. You can do 10 times some number equals 120. Maybe that gets it to you. Or you could have done 120 divided by 10, right? So 10 goes into 1 0 times. 10 goes into 12 1 time. 12 minus 10 is 2. Carry down our 0. 10 goes into 20 twice. So this means 120 divided by 10 is 12. Or if you ask yourself, what do you multiply 10 by to get to 120? Well, you multiply 10 by 12. And so what that means is that we evenly split 120 into 10 equal groups. So that means each group gets 12. And so when we do this, we end up getting that black has 12 black marbles and that red has, right, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can do 12 times 9 to get this. 9 times 12 is 18. Regroup our 1. 9 times 1 is 9. Plus 1 is 10. There's 108 red marbles. And so that's how you did your tape diagram. And so down here, when we explain our reasoning, right, we want to say there is 108 red marbles, right? But we don't stop there. I know this because I used our ratio of 9 to 1 red marbles to split our bag of 120 marbles into 10 equal groups. Now we're concluding this. As a result, I got 12 marbles in each group, and then multiplied by 9 to get 108 red marbles. Now we could talk about the black marbles if we wanted, but we don't need to. A lot of you guys did, which was awesome. So I'll leave this here for a second. You guys can pause it, read it, and use it to help you on your test. All right, so here we have, to make orange fizz, Noah mixes 4 scoops of powder to 6 cups of water. Andre mixes 5 scoops of powder with 8 cups of water. Create a double number line to represent both Noah and Andre's recipes to make orange fizz. So first off, we have Noah mixes 4 scoops of powder with 6 cups of water. And so we can write 4, 6. While Andre mixes 5 scoops of powder with 8 cups of water. So we can write 5 for powder, 8 for water. And so now what we want to do is we want to compare these by making a double number line or a table, which I will make soon. And so we can fill these lines out by just adding over and over. 4 plus 4 is 8, 12, 16. I'm just adding 4 over and over. 20, 24, right? 6 plus 6 is 12. 12 plus 6 is 18. We get 20, right? Wait, I'm having a brain fart here. 6, 12, 18, 24, 30, 36. And so we added 6 over and over. Now we go to our next one for Andre. 5 plus 5 is 10, 15, 20, 25, 30. 8 plus 8 is 16, 24, 32, 40, 48. And so we want to create a double number table. Well, we created our double number line. Now, how do these two mixtures compare in taste? Explain your reasoning. Well, what you need when you compare ratios is you need either your powder to be the same or your water to be the same. And what we can see here is that we have our powder being the same at 20. And so here Noah uses 20 scoops of powder and Andre uses 20 scoops of powder. And so that means their ratio was 20 scoops of powder to 30 cups of water, while Andre's ratio was 20 scoops of powder to 32 cups of water. And so when we compare these ratios, right, both the powders are the same. And so what we want to do is we want to compare the water, right? Andre uses more water with his powder. And so what's that going to do to the taste? Well, it's going to water it down. That means Noah's is going to taste a little more orangey. And so what we can write is Noah's orange fizz will have a stronger orange taste. We don't stop there, right, guys? We say, I know this because Andre uses more water than powder, As a result, Andre's fizz will be more watered down. Let's say you wanted to make a table here, right? Just to help you with this. So here we have powder and water, powder and water. Andre used 5 to 8. Noah used 4 to 6. What you need to figure out here is, right, what multiples does 4 and 5 share? Well, the multiples they share is 20, right? 4 times 5 is 20. And so you do 5 times 4. You do that to both sides, right, to get 20 scoops of powder to 30 cups of water. And again, you do that here, right? You want to get to 20, 5 times 4. So that means you do 8 times 4, which is 32. And so this is how you could use a table to get your answer down here. The only problem with using a table here is you need to know that the least common multiple is 20. Or if you wanted to do the least common multiple with your water, it would have been 24. And we could see that in our double number line here, that when there's 24 cups of water, Noah uses more powder. And so this is another example of where Noah is using more powder compared to water, while Andre is using less powder, right? 16 is more than 15, so that means Noah's will taste more orangey. I hope this study helped. I'm really excited to see your guys' revisions. Later.